Okay. Today, at the end of the lesson, you will be able to describe what inertia is and how it plays a role in motion and determine the direction of acceleration by the net force, by the motion of an object, and by a velocity versus time. Okay. So, I don't know if you have ever been to a bowling alley and you or someone you've known has been like, watch this slow roller. Okay, how would you describe on a bowling lane the motion of that bowling ball?
Moving. It's moving.
Moving, continues to move, right? What makes that like? So, like, why does it continue to move at a fairly constant speed? Okay, so I applied a force to it initially, but after I let go, was I applying a force to it? Okay, so why does it want to keep on going? Inertia. So an object at rest wants to stay at rest, and an object in motion wants to stay moving at a constant speed in a straight line path. That's what it wants to do. You right with that? And you remember the last time you were in outer space and you threw a ball? What did the ball do? Just kept on going. Like, oh, I really like that ball. Oh, shoot. Okay. On Earth, when things are moving, what do they naturally want to do over time? Or sorry, what do they end up doing over time? Not what do they want to do, but what do they end up doing?
Slowing down.
Slowing down, eventually stopping, right? Why?
Friction.
There are other forces at work. Friction, air resistance, okay? This is why air hockey table looks so cool. It gets rid of most friction. So the puck just goes. All right with that? Okay. So here's what I want you to walk away from with this. If an object is moving, it naturally wants to keep moving. Okay? That is its sole desire. That's the role that inertia plays. Like, let's just keep on moving. We have no problem with the fact that something at rest wants to stay at rest. That's not weirdos. Like the stapler on the table. We don't ever expect that just to go without something causing it. Okay, that's easy. But something in motion naturally wants to stay moving. Okay? Good? All right. So, continue to roll. Okay, because of inertia. So, the bowling alley gets rid of a lot of friction. You guys ever stepped across the line by accident? The lane, bowling lane, like,
Or literally seeing someone get yeeted into oblivion.
Yep, that too. Okay, good with that? All right. So, what I have here is a fan cart. Okay. And we're going to start this at rest. would you describe how that moved? Did it stay at rest? Speed up? Or move at a constant speed? The answer is,
Speed up.
okay, it started at rest and now it's moving, it had to speed up. Okay with that? Okay, so which way did the cart experience the force? Not which way the fan was blowing, but which way did the cart experience the force?
When the fan was, when it
To the
started.
right or to the left? Which way did the cart was pushed? Which way is the cart pushed?
Towards the left.
We're okay with that? Okay, and therefore it experienced acceleration
In a negative direction.
to the left. Okay, and this, if we say to the right's positive and to the left's negative, experience an acceleration to the left in the negative direction. Good with that? Okay, now, let's say it's moving to the left and I turn it on while in motion, so it's moving. It's kind of hard to see, but are you okay with the fact that it sped up? So it's rolling. And now is speeding up. Okay? I would also say that the acceleration is going in that direction. Okay? Now what happens if it's rolling this way and then I turn it on? What did it do? Okay? Which way was the fan cart pushed? Sorry, let me clarify that. After I let go of it, so pretend that I'm not part of the demo. Okay? You just happen to see a fan cart rolling that way. And then the fan was turned on. During that process, which way was the cart being pushed by the fan? Okay? The force causes acceleration. The direction of the force, it will always be in the same direction as the acceleration. Okay with that? Okay. So, from the video, Newton's second law was proposed to put up there. Did I do this? Did I show you this? The sum of the forces, the total force? Did I just do that on the video, or was the E there? Okay. Sigma. That was a rough one. So, is mass a vector? Does mass have direction?
No.
No, that would be wacky. Acceleration has direction, and so does force. So whatever the direction of the force is, that is the same direction of acceleration. Whatever the direction of acceleration is, that is the same direction as the total force. From a cause and effect point of view, the total force, the net force, causes acceleration. Because inertia just wants to maintain whatever it's doing. Like, hey, if I'm moving, let's just keep on going. But then the force is like, come on, let's do something different. Like, ah! I like to change. And acceleration is all about how quickly that change is taking place. You all right with that? Okay. Tell your neighbor.
Maybe.
Tell them why you think so.
Shit, but not everybody can be honest, bro. Not everybody can be a 122.
Shit, I know you studied for these jokes.
No, I know.
You're still moving in the positive.
If it's okay, I'm not gonna do
I think my Spanish
because
Oh, really?
she's slowing down, so it'd be the opposite of
Yeah,
the
99.5
velocity.
Wait, how many people in this room asked you if you said first?
Correct answer is
B.
B. Good with that? She's moving in the positive direction, but slowing down. Therefore, she's gonna have a negative acceleration. The direction, which way is friction, which way are the force from the brakes acting on her, causing her to slow down? Positive or negative direction? And then negative direction. Therefore, acceleration is also in the negative direction. Good with that? Tell your neighbor.
Maybe.
Is it only negative acceleration because there were brakes? Like if I was just slowing down in the positive direction, would it still be a negative acceleration?
It would be. That'd just be less.
And that's fine, it's good.
Correct answer is?
A.
Oh. Find someone you disagree with. Heard A's and B's. Find someone you disagree with. Convince them that you're right and they're wrong.
I thought it didn't matter. Right now it's the velocity. Oh wait, yeah, it's going in the negative direction.
Yeah.
But it doesn't.
I kinda
work.
would.
It doesn't matter.
Correct answer is?
A.
Okay. Which way is the boat being forced?
Negative direction.
Boat is being pushed this way to make it speed up. Therefore, acceleration has to be in that same direction. Okay?
So if you're slowing that, be positive, right?
Yes,
Okay.
in this example. All right, so here are the two different ways you figure out the direction of acceleration. First way is what we've been talking about, Newton's second law. So the direction of the force will always be in the same direction as acceleration. Okay? And that, for whatever the direction of the force is, that's always in the same direction as acceleration. Okay? The second way to do that is if speeding up, then velocity and acceleration have the same direction. If slowing down, the velocity and acceleration have opposite directions. So the direction of the way it's moving, that determines velocity. Okay, and displacement. But the direction of acceleration, well, that's not quite so straightforward. Okay, in terms of the motion. It's straightforward in terms of the force, but in terms of the motion, you need to know some stuff. Okay? Here's the pitfall. Don't associate speeding up with positive acceleration and slowing down with a negative acceleration. That's the pitfall. That's the popular thing. Like, oh, it's speeding up, it's gonna have a positive acceleration. This is why I hate the word decelerate. Okay? It leads people to think, oh, it's decelerating, it's negative acceleration. Maybe. Oh, we're seeing that? Like, that's a pitfall. That is a trap that is deep. Okay? Good? Question? Okay, next question. Is the Roadrunner still in your childhood? Is that a thing?
Oh, these little birds that just goes meep, meep.
Okay. I mean, just,
Yes.
sometimes childhoods kind of evaporate. Calvin and Hobbes, yes, no?
I've heard of.
Yeah, see, that's like, killer.
I've heard of Bugs Bunny.
Very weird.
Thumbs up when you got an answer for this. Tell your neighbor and tell them why.
You're slowing down, so it'll be the opposite of velocity.
No, he just said because it slows down, that doesn't always mean it's negative.
Correct answer is solid. Okay? You're slowing down while moving in the negative direction, therefore acceleration is in the opposite direction. Positive. Which way is the force acting on Coyote to make him slow down? Has to be going this way. Good? Be comfortable with explaining it both ways. Okay? So, here, what I'm gonna do is I'm going to push this that way with the fan on, okay? And I'm gonna leave it on for a while, okay? Ignore the pushing part. We're just assuming that we just randomly saw a fan cart rolling that way, okay? Do it again. Okay. As it's rolling this way, which way is the cart being pushed? Right or left? Sorry, not by my hand, but by the fan. Which way is it being pushed?
Left.
Left. Okay, what's the direction of acceleration? Right or left?
Left.
Also left. Whatever the direction of the force is, that's the same direction as acceleration. And this thing did what? Speed up or slow down? Slowed down. As it was coming back this way, was it speeding up or slowing down? Speeding up. Therefore, the direction of acceleration is right or left? Also left. If an object experiences acceleration in the opposite direction it's moving, then over time, it will slow down, stop, and speed back up. Okay with that? Yeah? Try that question. Thumbs up when you have a guess. Tell your neighbor. Tell him why.
Acceleration.
Yeah, I don't know why.
Because it slowed down. They changed 6 over 1 second.
Correct answer is? Okay, mathematically, acceleration is equal to final velocity minus initial velocity over time interval. Yes? So I have final velocity is a negative 3 meters per second minus a positive 3 meters per second for the initial velocity all over 1 second. Correct answer is? A. Okay, in order to go from moving in the positive direction to moving in the negative direction, I would need to stop or slow down, stop, turn around, and speed back up in the negative direction. Experiencing an acceleration of negative the whole time. You all right with that? Next question. Thumbs up when you have a guess. This question usually invokes a good conversation. Go ahead and have some. Tell them why you think so.
They could both be going the same direction, one of them's just slow down and speed up. We don't know this just speed.
Well, think about it. They're going in opposite directions. I'm
We
not
don't know
sure if
if
going in negative and
this down is
slow
down.
They're slowing down. Yeah. So A is out, which also runs C. Yeah. And D can go against both.
We know using the second one because they can start at different speeds.
Direction of velocity.
Negatives, it could have negative. be going in the same direction.
Yeah.
And
So even though I think way too far into that.
I'm just trying
I
to
think
think.
we're doing it.
The acceleration is
Oh, yeah, yeah, yeah.
forces I
Yeah.
Yeah, what do you say? Alphabet soup. All right. So, could they be going in opposite directions? Yes. Do they have to be going in opposite directions? If these are velocities, then yes, they would be going in opposite directions. But these are accelerations.
Oh. So one can be positive slowing down, one can be speeding up.
Hmm. Yes? Is everybody okay with that? Okay. Does the stallion have to be going faster? Or could the stallion be going faster than the mare? Does it have to be?
No.
No. Could the stallion be slowing down and the mare speeding up? Have to? You can conclude nothing about their motion based on the acceleration. The only thing you can conclude is the direction of the total force. That's it. Okay? The stallion could be slowing down, it could be speeding up, depending on if it's moving in the positive or negative direction. Same could be true about the mare. Good? It's a good question. I like this question. Next question. Thumbs up when you have a guess. Talk to your neighbor. Tell them why you think so.
Slowing down by going out, so it should be in the and speeding up as it goes down, so it's speeding
it's, oh wait, never mind.
I think it's B.
Other than it's speeding up.
Wait,
Like,
I love to change to. Or does accelerate? I don't know, you think so?
Correct answer is? Correct answer is B. As it goes up the ramp, moving in the positive direction based off of right here, just slowing down or speeding up. Slowing down, therefore acceleration is in the opposite direction as the velocity down the ramp. The net force is going that way. As it goes back down, it's speeding up. Moving in the negative direction, speeding up in the negative direction gives you a negative acceleration caused by a force going that way. Good? Okay, we're getting this. Okay. Tell your neighbor and tell them why. Give them an explanation.
Force to a positive direction when it comes to
Slowing down is it's in the negative direction, but it's slowing down.
So yeah, stop.
Slowing down in the negative direction, which would be what?
What if you want it to be in the 20 direction?
And plus, acceleration graphs cannot be so
Yes. I thought that. Now, it's not.
but it's negative. We don't reach.
Negative.
Correct answer is?
A.
Correct answer is A. Got two different explanations. You need to be familiar with both of them. You got the story, and then you have the graph. How'd you move to make this graph? Are you moving in the positive or negative direction? You're in the negative direction. You're in negative land. Okay? Are you speeding up, slowing down, or staying constant?
Slowing down.
You're slowing down. So if you're slowing down while moving in the negative direction, you're going to have a positive acceleration. That's this concept. That's the story. This have a positive or negative slope. There's a positive or negative slope. Positive slope. Is the slope changing or is it constant? The constant positive slope gives you a constant positive value of acceleration. Okay, you gotta be familiar with both sides. Both ways to explain. Next question. Your neighbor?
C, B. B because orange is slowing down.
I think it's.
Acceleration is, acceleration is not direction.
Huh?
It's just.
This one?
No, it's,
I was like, it's B.
yeah.
Let's see.
So then, yes, you guys are probably.
Slow, same slow.
Correct answer is?
C.
Correct answer is C. Okay. Mathematically or graphically, they have parallel slopes. They have the same slope. Okay. This is slowing down in the positive direction, negative. This is speeding up in the negative direction, also negative acceleration. Wait for it. Your neighbor? Tell them why.
the slope was constant going.
Slowing down in opposite directions.
Wait, so
Yeah.
turning around and speeding up.
There's two negative, negative, positive.
I'm
Well, because it's like the car, it's going forward, slowing down, and then going in the other direction, it's still always positive.
But at first it was positive direction.
The fan turned off for a second, something else.
Yeah.
And we all think B, we think B.
Correct answer is? Well, I guess let's have a conversation. All right, during this first half, would you move to make that graph?
Slowing down in the positive direction.
You're slowing down in the positive direction. Therefore, you have a what sign? What's the direction of acceleration?
Negative.
Has to be negative. Yes? Slowing down in the negative direction. C is out. E's out. D's out. You all right with that?
Yeah.
Okay. The second half, how would you move to make this happen?
Speeding up in the negative direction.
You're speeding up in the negative direction. Speeding up in the negative direction meaning you have to have a what acceleration?
Negative.
A negative acceleration. That makes sense?
Yeah.
Okay. So now we have this conversation between A and B. Okay. The point of contention is that point right there. What happens right at that point?
Stop.
Stops. For how long is it stopped?
Maybe like
Not at all.
Just a moment. You okay with that?
Yeah.
Okay. The moment right beforehand, was it moving? The moment right afterwards, was it moving? So from moment to moment to moment, was the velocity changing? Therefore, you have acceleration the entire time. Here's another argument. Did the slope of this line ever change? There's a constant slope, therefore a constant value. Okay? If I did that, so this is what happens here. With the fan cart. That's that graph. Actually, sorry. Yeah. Yeah. Start. Stop. Good at that. Okay. Slow down. Stop. Stop for just a moment. Kept going. Last question. Yes, please. And hang on. Have a conversation.
C. Because D is starting slow, but it's super low. So it's more of a positive C. It's going faster.
Correct answer is
C.
C. Has a steeper positive slope. So higher positive value. This has a shallower negative slope, so closer to zero, but negative. Good?
Yeah.
Got a worksheet due tomorrow over acceleration.